Welcome to the first video of Chapter 5, which covers Section 2, Use Perpendicular Bisectors. Chapter 5 is a continuation of triangles. This chapter is going to be talking about a whole bunch of different types of relationships within triangles. The first three sections that we're going to do are 2, 3, and 4. And these sections all talk about certain triangle centers. So each section we're going to learn about a new triangle center. Today we're going to learn about the center that is formed by perpendicular bisectors. So there's two objectives. We're going to determine if a given segment is the perpendicular bisector, and then we're going to find the side lengths using properties of the perpendicular bisector theorem. So a few definitions. We should probably first talk about what is a perpendicular bisector. A perpendicular bisector is a segment, ray, or line that passes through a segment's midpoint and is perpendicular to the segment. So drawing ourselves an example, if I have some segment and I put my midpoint in, so that's how I show it's a midpoint. The perpendicular bisector is going to go through that midpoint, so it's going to bisect the segment, and it's going to be perpendicular. Okay, next term is equidistant. Equidistant just means equal distances. Okay, so you're probably thinking to yourself, well, why do I need to know that? Well, both of these terms together are going to lead us to the perpendicular bisector theorem. The perpendicular bisector theorem says a point on the perpendicular bisector of a segment is equidistant from the segment's endpoints. So drawing ourselves a picture again. Here's my segment, here's my midpoint. My perpendicular bisector is going to go through that midpoint, and it's going to be perpendicular. Okay, so now this theorem says any point that's on the perpendicular bisector. So this point, let's say, it's going to be the same distance from the two endpoints of the segment. So those two dashed lines that I drew in are going to be congruent. Okay, the reason that they're congruent is because these two triangles that are formed are congruent. So if the triangles are congruent, then all their corresponding parts are congruent. So really in this theorem, you're going to be looking for congruent triangles. So let's look at an example. In example number 1, it says BD is the perpendicular bisector of AC. Find AD. Okay, so firstly, we are told that BD is the perpendicular bisector. So let's mark that. We know that BD is going to be perpendicular to AC, and it's going to bisect AC. Now, here's how you're going to solve this problem. I'm asked to find AD. Now, point D is on the perpendicular bisector. Therefore, it is equidistant from A and C. So CD and AD are going to be congruent. So you know that you can do 3x plus 14 equals 5x. If I subtract 3x, I get 14 equals 2x, and x equals 7. Now, the question specifically asks us, though, to find AD. So to find AD, I'm going to do 3 times 7, and I'm going to add 14. So 3 times 7 is 21. 21 add 14 means AD is going to be 35. Okay, CD, if you're going to notice, 5 times 7 is also 35. This is a good way to check your answer. We know that these segments are supposed to be congruent. In this case, because they are congruent, that gives us evidence that our answer is correct. Now, one thing to notice. When I drew in the perpendicular bisector, so I started by drawing in these right angles and then putting these congruency marks, that makes the triangles congruent. So BD is congruent to itself. Hopefully you remember from last chapter then that we have SAS that the triangles are congruent by. That's why their corresponding parts are congruent. So you have two ways of doing these problems. Either you need to remember that any point on the perpendicular bisector is equidistant, or you just need to look for congruent triangles. So let's look at the next example. Okay, in the figure below, which segments are of equal length? So what I want you to mark, which is not marked, is this right here. Okay, now when I mark that, that tells me that HI is the perpendicular bisector. It's perpendicular because it has a right angle. It's a bisector because I marked in that EH and HD were congruent. HG, that is. So which segments are of equal length? Well, obviously EH is going to be congruent to HG because they're marked congruent. Now, what other segments are congruent? Well, I notice I have two segments that are 25. So that tells me that FE is going to be congruent to FG. Now I'm also going to notice that this point I is on HI. It's on the perpendicular bisector. Any point that is on the perpendicular bisector is equidistant from the endpoints. So I also know that EH, or EI, I mean, is going to be congruent to IG. So here are all of my segments that are congruent. Again, looking at the congruent triangles. This triangle right here, I have a right angle. I have this congruency marked, and then HI is congruent to itself. So then that triangle on the left and the triangle on the right are congruent by SAS. Therefore, their corresponding parts are also congruent. Okay, so then the next question is F on HI? So basically, if I continue HI, is it going to go through F? That's what the question is asking. Well, what I notice is that F is equidistant. So it's the same distance from E as it is from G. So it's the same distance from the two endpoints. That means that F is on the perpendicular bisector of EG. Now, if F is on the perpendicular bisector and HI is the perpendicular bisector, that tells us that yes, F is on HI. Okay, if that was confusing, I know that I went quickly, so you're going to need to rewind the video and rewatch that part. If not, and that was clear, please move on. Okay, examples 3 and 4 I would like you to try on your own, please. Pause the video, try them on your own, and come back when you are finished. Okay, for example 3, find the length of AB. Now, you all probably could have guessed that you had to set 3x plus 8 equal to 7x minus 16. You would have ended up with x equals 6, and then AB equals 26. Now, it's more important to me that you know why this is true. So what you should have noticed is that you have a perpendicular angle and that your segment is bisected. That tells you that BD is the perpendicular bisector. Then you know that any point on that bisector, like B, is going to be the same distance from the two endpoints. That would have told you that AB and BC are congruent. That's one way to think about the problem. The other way to think about the problem is to look for congruent triangles. Now, these red, which I now went over in purple, those were already marked congruent, and we already had two right angles. Then BD is congruent to itself by the reflexive property, so triangles are congruent by SAS. Therefore, the corresponding parts are going to be congruent. So either way, you need to remember that a point on the perpendicular bisector is equidistant from the endpoints, or you need to be able to look for congruent triangles. So that was 3. Example 4. Does the diagram allow us to conclude that C is on the perpendicular bisector of AB? Explain. Okay, so the first thing that I want to do is I want to connect C to the other side. So I'm going to connect C to AB. And I'm going to do it in such a way that this segment is perpendicular. So basically I already know that my segment is perpendicular. I need to know if it is also a bisector. 2 ways to think about this. The first way is the Perpendicular Bisector Theorem, which says if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. In this case, my point C, is it equidistant from the 2 endpoints? Well, yes, I see that CA and CB are congruent, so C is on the perpendicular bisector. So that's the first way of thinking about it. So I'm going to say yes, C is on the perpendicular bisector because it is equidistant from the endpoints. Okay, the other way to think about it is, do I have any congruent triangles? Well, with the markings I have right now, I know that this segment is congruent to itself. Now I have my right angle, I have the hypotenuse, and I have the leg. The triangles are congruent by HL, therefore all of their corresponding parts are congruent, which means this would be congruent to that part. So yes, on the perpendicular bisector. So yes, C is on perpendicular bisector because the triangles are congruent by HL. So there's 2 ways of doing the problem. Either look for the congruent triangles or determine if the point is equidistant if a point on the segment is equidistant from the endpoints. So that was the first part of problem 4. Right now I want you to pause the video and check your answer for this second problem. I want you to reevaluate it. Determine, is C on the perpendicular bisector? Good luck. Okay, let's see how we did. Now the first way I told you to think about this problem is to determine, is C equidistant from the endpoints of the segment? In this case, that means, is CA congruent to CB? So is C the same distance from A as it is from B? Well, we have no reason to believe that. Could that be true? Yes. Is it necessarily true? No. So in this case, we would say, no, C is not on the perpendicular bisector because CB is not congruent to CA. So C is not equidistant from the endpoints. The other way I told you to think about this problem is to determine, do we have congruent triangles? Well, in this case, we have one set of sides congruent and another set of sides congruent. That gives us SS. That's not a congruency theorem. Not a congruency theorem, therefore it's not the perpendicular bisector. So we would say no, triangles are not congruent. So hopefully you got that right. If you didn't, that's okay. These problems are tough, and we'll do a few more examples in class. Now, we still have some more stuff to learn, so let's move on to a few more definitions. Concurrent just means that the lines intersect. So the point of concurrency is a point where multiple lines intersect. By multiple, I mean 2 or more. Intersect. Now, why is this important? Well, this is going to lead us to the next theorem. So the perpendicular bisectors of a triangle are concurrent. So that means all 3 perpendicular bisectors intersect at the same point. This point is the center of the circle outside the triangle, which means that point is equidistant from the vertices of the triangle. And I'm going to show you what that means in a minute. The point of concurrency of the three perpendicular bisectors is called the circumcenter. Okay, so I just want us to draw this in to see a little bit better what it looks like. So we're going to start by just drawing ourselves a triangle. Okay. Now I need to draw in my three perpendicular bisectors. So a perpendicular bisector is going to go through a midpoint, and then it's going to be perpendicular to the side. So here's one perpendicular bisector. Here is my next perpendicular bisector. And then my third perpendicular bisector, again, I make the midpoint. And then I draw it in such a way that it's going to be perpendicular to the side. Now remember, I'm drawing this by hand, but what you're supposed to see is all three of those points intersect, or all three of those perpendicular bisectors intersect at the same point. That point is called the circumcenter. Okay, now the circumcenter is important because it creates a circle outside of the triangle, and that circle passes through all three vertices. So that point is the center of this circle right here. Again, it's supposed to touch all three vertices, but give me a little credit. Now, this point is the same distance from all the vertices. That's because this point creates radii with the vertices. So this right here, from the vertex to the point, is one radius. That's going to be the same distance as this radius over here, and the same distance as this radius over here. Okay. I know this is confusing, so I think it's best if we just move on and try a few examples. So please flip the page. Okay, here's our next example. Example 5, it says, in the diagram below, point U is the circumcenter of triangle QWS. Find the indicated measure. So we are asked to find US. Okay, first thing we are told is that U is the circumcenter. Anytime that you are told you have a circumcenter, I would like you to draw in the circle outside of the triangle. So circumcenter, it means the circle is going to go through all three vertices. So it doesn't have to be perfect, but do your best to draw the circle between all three vertices. Now I want you to draw in your radii. So your radius is going to go from the center U to the outside of the circle. So UW is one radius, US is another radius, and QU is another radius. Now all radii are congruent. So if QU is 14, then US is 14, and UW is also 14. So US in this case is 14. Okay, pause the video and try B on your own, please. Come back when you have finished. Okay, let's see how we did. First thing that you should have done is drawn your circle outside of the triangle. So your circle is going to go through the three vertices, so B, C, and A. Now I want you to identify what are my radii. Well, they're all going to start at G and go to the circle, the outside of the circle. So GB is one radius, GC is another radius, and GA is a third radius. Now, GB is 13. That means GC is also 13 because it's a radius, and GA is also 13. So the answer you should have gotten is 13. Okay, hopefully that went well. If it didn't, you have one more opportunity to prove yourself. Here is the last question. This is the question that you're going to do on your own right here. So in this video, we went over two things. We went over whether or not a given segment is the perpendicular bisector, and then we found side lengths using the perpendicular bisector theorem. Remember, it comes down to remembering one of two things. Either you look for the congruent triangles, or you determine if a point is equidistant from the endpoints of the segment. In the last part of the video, we learned about the circumcenter. When you come to class tomorrow, I'm going to be making sure that you have all of these problems finished, including the last problem. For this last problem right here, you need to show work of some type. So I know that you thought about the problem and didn't just write down random numbers. Good luck, and please bring any questions you have to class tomorrow.